Hi, this is Math 1350, and this video is over section 7.4, and we'll be looking at systems of nonlinear equations. And we'll be going through the same methods that you guys would have learned for systems of linear equations. It's just we have to look for multiple solutions, and it's not as simple as just solving a linear equation or multiple linear equations. So the first one is the graphical solution. So I'm going to pull up Desmos, and we're going to plug these equations in. And the good thing is we don't have to solve for 0 or anything like that. So just x squared plus y squared equals 9. And we see we got a circle there, radius 3. And then the other one is x minus 3y equals -1, and we have a line that goes through. And so we can see by graphing it, we have -2.93 and -0.64 as a solution. So -2.93 comma -0.64. And then the other solutions on the other side, 2.73, 1.24. Okay, so if x is 2.73 and y is 1.24 roughly, both of these equations are true. And if x is -2.93 and y is -0.64, both of these equations are true. And so again, graphing is a way to get quick answers, but notice these are not exact answers, they're approximate answers. To get exact answers, we have to go through the other methods. Okay. So let's look at the substitution method. It follows the same method you would have learned before. You isolate one of the variables and then you plug into the other equation. And so in this case, we're going to isolate x, since that seems to be the easiest one to solve for. So x equals -1 plus 3y. I'll write this 3y minus 1. And then we're going to plug that x in for x squared here. So we'll have 2 times 3y minus 1 squared plus y squared equals 1. And so now we have just a quadratic we have to solve. So to do this, we're going to first FOIL out the 3y minus 1. And so we'll have 3y minus 1 times 3y minus 1. And I'm going to set this equal 0 by subtracting 1. Okay, so when I FOIL this, I'll get 9y squared minus 6y plus 1. And then multiply in the 2, so 18y squared minus 12y plus 2 plus y squared minus 1. And then put like terms together, we'll have 19y squared minus 12y plus 1 equals 0. Now this is not going to factor, so we'll have to solve it by solving in quadratic. So x equals 12 plus or minus square root of 12 squared, so that's 144, minus 4 times 19 times c, which is 1. So 4 times 19 is 76. And then this is all over 2 times 19, which is 38. So that's just a quadratic equation. And so we can simplify this. 12 plus or minus 144 minus 76, which is 68. And if I divide that by 4, I get 17. So I'll make this square root of 4 is 2. So 2 square root of 17 over 38. And then I can reduce this down to 6 plus or minus square root of 17 over 19. And so these have two possible values for x. 6 plus the square root of 17, and then the whole thing divided by 19, which is 0.3532 or 533, so 0.533, and then 6 minus the square root of 17 divided by 19, which is 0.099. And of course I can plug these in then, actually before I forget, these aren't x's, these are y values. Right? We had y as a symbol. So I can plug these in for y and get an x value. To do the exact, I would have to plug in the exact value for it. So I'm going to start with the exact to get the x values. So x would equal 3 times 6 plus square root of 17 over 19, which is going to be 18 plus 3 square root of 17 over 19 minus 1. Let me put that in here, minus 1, minus 1. So I can then make that with the minus 1. We'll have that as 19 over 19. And so I'll write this as 19 over 19, so this will be negative 1 plus 3 square root of 17 over 19. And so get exact value, you can plug this in. You get 0.598. Right, so that's the first solution, is 0.533, 0.598, and then the next solution, 3 times 6 minus square root of 17 over 19 minus 1, be 18 minus 3 square root of 17 over 19 minus, I'll make that 19 over 19. So negative 1 minus 3 square root of 17 over 19. So these are exact values for the x values. So negative 1 minus 3 square root 17 divided by 19. And we get 0.704, negative 0.704. So the solution would be 0.099, negative 0.704. And then we have the elimination method here. We try to adjust the equation so one of the values drops out. You can drop out either one, x squared or y, it doesn't matter. I think the easiest way would be multiplying the top by 2 and dropping out your y's. So we'll have 4x squared plus 2y equals 20, and then x squared minus 2y equals negative 5. When we add down, we get 5x squared equals 15. So x squared equals 3. So x equals square root of 3, which is plus or minus. This is about 1.73 or negative 1.73. Now that we found our x's, we can plug things in for y. The easiest way to get a y is to solve the top for y. So y is 10 minus 2x squared. Now, no matter what you plug in, negative or positive square root of 3, when you're squaring it, you're going to just get 3. So both cases will end up with 10 minus 2 times 3, which is going to be 6. So 10 minus 6 is 4. And so your solutions here are square root of 3, 4, and negative square root of 3, 4. Alright, last question in this section. A company produces two types of products, A and B. The total revenue R from selling X unit of products, A and Y units of products B, can be modeled by the equation R equals 5x squared plus 4y squared. The total cost for producing X units of product A and Y units of product B is given by C equals 2x squared plus 3y squared plus 12. If the company wants the revenue and cost to be equal and also to produce 4 units of product A and B combined, how many units of each product should the company produce? So first, the products A and B. So we'll just use A and B for these. Actually, hold on, it says X is units of product A, so we'll use X for A, Y for B, and it has to equal 4. So that's the first equation. And then it wants the revenue and cost to be equal. Right, and so we're going to set these equal. So 5x squared plus 4y squared equals 2x squared plus 3y squared plus 12. Okay. Now I'm going to solve the first equation for one of the variables. We're going to say, let's just say y. Y equals 4 minus x. And so we can plug in y equals 4 minus x for the y's in the other equation. So we'll have 5x squared plus 4 times 4 minus x squared equals 2x squared plus 3 times 4 minus x squared plus 12. Alright, so let's simplify this out. 5x squared, I'm going to multiply out the 4 minus x. So I'll get 16 minus 8x plus x squared equals 2x squared. And FOIL this out again, 3 times 16 minus 8x plus x squared plus 12. And multiply in the 4, multiply in the 3. I'm also going to just subtract over the 2x squared while I can. So 3x squared plus 64 minus 32x plus 4x squared is 48 minus 24x plus 3x squared plus 12. Alright, I want to get everything on one side here as soon as I get common things together on each side. So 7x squared minus 32x plus 64 is 3x squared minus 24x plus 60. Alright, so now move this all over. We get 4x squared minus 8x plus 4 equals 0. I can factor out 4. X squared minus 2x plus 1. And then this factors x minus 1 times x minus 1. And so in this case, x is going to equal 1 unit. That will make those two equations equal. And so then we find y. And so y is going to equal 4 minus x, which is going to equal 4 minus 1, which will equal 3 units. Alright. In the last video, we're going to do systems of inequalities. It's going to be a really short video. We'll just go through one example. But I still want to separate these videos and not make this too long. Alright, I'll see you guys then. Bye.